First, I'd like to go over a few of the things related to the webinar. You should have some controls over the webinar. You should be able to see a chat window if you need to. You can either reach just directly to me, or you can reach everybody with that. You can also ask questions at any time during the webinar with the Q&A button. And what we're going to do is hold off on answering these questions until the end. If it's something that I can answer, I'll go ahead and answer it in the window. If not, then we will cover those toward the end. And if you have any real difficulty, you can raise your hand. There's a raise hand button, and I will reach out to you through the chat so that we don't disturb the webinar ongoing. So in the meantime, let's go ahead and get started. I'm going to say a few words about LF Energy, and then we will turn it over to Debbie and Michael. So this picture that's behind the text here is a picture of the internet. It's a map of the internet as it was, I think, 2 years ago. And it's obviously very complex and convoluted, and it looks very much like a brain that has grown organically. And it's very different from the internet from the 1970s, which was just a number of nodes that looked more like a subway map. And that is a very different set of, it's a very amazing scale if you think about it. There's a, it went from a couple of dozen nodes to now billions of nodes, and slated to become many more billions of nodes as the Internet of Things becomes more of an issue in the world. And one of the things that Shuli Goodman is the executive director of LF Energy, and one of the things that Shuli likes to say is that we need to leverage the same design principles for the system, that we want to be able to look back on the 20 and say like how we did. And ways to do this, one of the only really effective ways to do this is by leveraging open source software. So if we want to move to the next slide, please. The way to do this is to leverage the world's largest shared technology investment, which is open source software in general and the Linux ecosystem in particular. The Linux Foundation, which has been around for about 15 years, is the organization, it's a nonprofit organization in the US that shepherds the Linux ecosystem. There are about 190 projects, including the Linux kernel, within the Linux Foundation. It's made up of roughly 200 employees, one of which is me. We basically do whatever we need to do to make sure that these projects succeed, and to share the design principles and the practices, the best practices of open source. Next slide, please. The mission of LF Energy in particular is to build the grid of the future. And what that looks like, of course, is, a lot of people have different ideas of what the grid of the future should look like. What our vision is that it's composed of loosely coupled systems, as opposed to the tightly coupled hierarchical systems that exist today, that are resilient, manageable, and observable. And this is, all of those adjectives are extremely important, particularly the loosely coupled systems, because the way things are now with the grid, it is very hierarchical, and it's difficult to integrate renewable energy. And what we would really like to be able to do is to design software that can help with that transition. The LF Energy's, sorry, go ahead. The mission is to accelerate the energy transition by fostering and sustaining an ecosystem of open source vendor neutral projects. Vendor neutral is also a very important adjective here. One of the aspects of projects that Linux Foundation operates is to make these projects as vendor neutral as possible, and that means bringing as many people into the mix as possible, and as many different companies, as many different organizations, governments, whoever can help. The many hands do make light work in this situation. Okay, we can go ahead now. Safe, shared, and scalable code is really the goal for the project. We feel that that's one of the ways that we can contribute to this energy transition. Most industries today run primarily on open source modules and APIs, creating a platform of a global community of software developers that can enhance, test, and build new products and services. That's a bold statement to say that most industries run primarily on open source, and it's actually very verifiably completely true. One of the things I like to bring out is to just imagine how many computers there are between me in Oregon talking about these slides over this internet connection, and then you reading them from wherever you are in the world, and that there are probably 30 or 40 computers in between internet routers and all of that. And a very large number of those are running open source software, particularly in the telecom world. There's no way there would be no way for those things to scale otherwise. Open source supports business agility, it preserves IP, it is more flexible, economical, and safer than any alternative. And all of the projects within the Linux Foundation have proven that many times over. Okay, next slide. So these are the current projects we have underneath LF Energy as an umbrella. You can see that there are two projects that work together underneath flexibility as far as markets go. OpenEE Meter and EM2 are built around measuring energy efficiency in buildings, and being able to affect that energy efficiency that makes things much more flexible. There are opportunities under generation, under residential control, commercial and industrial control. We've actually got REAPs already working with microgrids there. Cybersecurity is a huge issue that we hope to address. We have one member at least who's a cybersecurity company. And OEDI, of course, is the Open Energy Data Initiative down here, which will provide data lakes, data access, privacy, and security. People will be able to identify pain points by examining the data. And I'm really excited to learn about all this. New projects forming right now. There's a digital substation project that's forming. We're looking at predictive maintenance, hopefully smart grid automation, and we encourage all of you to become a part of this if you can. I got one more slide, I think. I'm going to go over, these are the founding members. The project really just launched, did its code launch about a month ago. We have 23 members, of which NREL is one of them down here underneath the associates. And we would very much like to see your organization on this list. So again, if you have any questions during the event, let me know. You can reach me through the chat, you can reach me through the Q&A, and let's turn it over to Debbie and Michael.
Great, thank you so much. Thanks for the introduction and also for the invitation to talk today. I'm Debbie Brodt-Giles. I'm also in the room with Mike Rossol as well as David Rager. John Weers is also on our team, but he's traveling today, so he's not with us. But we are here to talk about the Open Energy Data Initiative and the work that we're working on related to this project. First, so what is this thing called OEDI? Basically, it's an Open Energy Data Initiative that's really striving to automate the access of high-value energy data. It is sponsored by the U.S. Department of Energy, and the National Lab, of course, is one of the national labs that works very closely with the Department of Energy. For many, many years, NREL has been working on open data projects. We have a project called OpenEI that we've been working on for really about 10 years. And this project is really kind of taking OpenEI and building new ways to access data in a whole new way, and really accelerating that data access for the world's use. So why is something like this needed? You know, there is a lot of data out there, especially when you're talking about energy data, and data can be difficult to find and use, especially in like a research community like a national lab system. So, of course, the Department of Energy has a lot of great data sets that they want to get out for public use, as well as NREL, as well as all of the other national labs. So really, the idea with Open Energy Data Initiative was to start with the federal data sets that we have control over and try to get as many high-value energy data sets out there for use and reuse as possible. But in doing so, there's also a lot of other data sets, and we want to make sure that the data is very accessible and usable with other data sets as well. So that's why we are going towards the data lake concept that we'll talk about a little bit later as well. But really, there's a lack of publicly available data. Sometimes we create data within our lab structure, and sometimes, by no fault of anybody's, it just doesn't make its way out there for public use. So what this program is trying to do is identify those high-value data sets that will be very valuable to the public and try to get those out there so people can use it. Also, data oftentimes is not in standard formats or sizes, and the work that we're doing in this program and utilizing tools in Amazon and other cloud providers will help us get access to data and kind of improve the standardization between those data sets as well. And then some of the data is very, very large, so it can be very costly to store this data and especially costly to transfer this data for use. So we're trying to address all of these problems with this project. So I'd like to now turn this over to Michael. He's going to talk a little bit about some of our use cases, some of the first things that we've been working on related to this project.
Thank you, Debbie. So yeah, my name is Michael Rossol. I am a data engineer at NREL, working in Debbie's group and working on OEDI. And one of my primary roles here at NREL is to manage our two very large resource data sets. So that is the National Solar Radiation Database, NSRDB, and the Wind Integration National Database, often known as the Wind Toolkit. So as you can see here, these are quite large data sets. The NSRDB covers about 20 years of historical irradiance data for the Western Hemisphere. It's at 4 kilometers spatial resolution, 30-minute temporal resolution. It's about 40 terabytes on disk. The Wind Toolkit is even larger. It's 7 years of 2-kilometer, 5-minute wind resource data for just the contiguous United States. And in its raw format, it's about 400 terabytes. Both of these data sets are kind of some of the premier flagship data sets of NREL. They get a lot of interest where you can see on the right here that we get hundreds of thousands of requests a year for this data. And this is a really, really great example of what Debbie was talking about a data set that we've had that is meant for public use, but historically has not really been fully accessible due to technical issues. So this is the current platforms for public access. There are 2 websites, the NSRDB Viewer and the Wind Prospector. They're hosted internally at NREL, and due to technical issues, server size, bandwidth, etc., they only make a very small portion of the data available, or you're only allowed for very small downloads. So all of the NSRDB data is available, but the request sizes are very small. You're limited to several thousand sites per year per download. The downloads have to be pre-processed, so it's not in real time. You'll get an email with a link. And for the Wind Toolkit, it's an even bigger issue. We only make about 1/40th of the data available. So it's about 2 terabytes of data that we're hosting. It's 125,000 sites and just one of the 9 hub heights that we have available. So it's a really small amount of data compared to the full data set that we created. And this is where OEDI comes in the cloud. By migrating the data to the cloud, we can make all of it available. So all 32 terabytes of the NSRDB, we're making 50 terabytes of the Wind Toolkit. So hourly data for all years, all locations, all variables available in the cloud. And this means that you can get real-time access and you can download much, much more data. So here's an example. We downloaded every single NSRDB data point for California for all 20 years. It's about 20 gigabytes of data. And we could do that in a matter of minutes to about an hour for all that data. This is something that we could not accomplish with the existing framework and in resources that we have with the NSRDB viewer. You just can't make that much of a request. It's not physically possible. So this is really opening up analysis using these data sets by making it available on the cloud in real time and giving the public access to much, much larger amounts of the data. So kind of a couple of examples of what's in the data. So the NSRDB is kind of it's an agglomeration of a bunch of different sources. The irradiance data is computed using the GOES satellite imagery data, which is the cloud cover is extracted by the University of Wisconsin. We then integrate that with a bunch of other data sources. MERA2 gives us a lot of our weather variables. We get albedo from a couple of other publicly available satellite data sets. And then we have some climatology data to make predictions of aerosols that are needed for the irradiance calculation. So all of this is run through the physical solar model developed here at NREL and provides irradiance as well as all of these input variables at the 4 kilometer 30 minutes I mentioned earlier. So here's an example of kind of what that data set looks like. This is 1 day of direct normal irradiance, and you can see the clouds moving across the country. So it's a very high resolution data set with a lot of value within the solar community. And then this is an example of kind of the wind toolkit. So this is actually an applet that you can run through GitHub. This is pulling data down directly from the cloud using our HSDS service, which David will talk about in a little bit. And this is showing Superstorm Sandy. So you can really see, again, the resolution and the fidelity of the data that we are providing via OEDI and Amazon. And now back to you, Debbie.
Great, thanks. All right, so this project, what are we trying to do with OEDI? Basically, there's 3 big elements to it. First, we are trying to really partner with all of the cloud providers that are out there. NREL has a history of working with Amazon Web Services. We have an authority to operate within that environment, so that's where most of our applications are today. But we want to open that up. We want to have partnerships with all of the cloud vendors that are out there, including Google and Azure and IBM and others. And so we are opening up those conversations with the cloud partners and trying to kind of cast a wider net and really work with more of those cloud vendors. We are also really focused on making our data sets easily accessible and especially trying to increase innovation related to those data sets. And then also the whole idea of this data lake and analytics we'll talk a little bit more about, but that's kind of the heart and soul of what we want to do on OEDI. So really, when I was discussing the cloud partner relationships, we're building off of a model that NOAA actually created over the last several years. So NOAA has great success in partnering with many cloud vendors to help host some of the really high value data that NOAA has. So we are exploring similar relationships because we kind of feel like, it's a good thing to have this data, this high value data hosted in a number of different locations and being accessible in a variety of ways. So we are, like I said, working with those partnerships right now and looking to build those relationships. When we're talking about the data set access, what we really want to do is make our data useful and usable and relevant so that people can get access to this high value data that's never been available before, really, like the example that Michael just gave. So we want to also increase the visibility of these data sets and really distill this data into actionable information that people can use to mash up data with their own data sets as well. So we want to engage our stakeholders and really collaborate. We want to create new data sets. We want to collect new data sets. So, in this world, especially with us working with LF Energy, we really are looking to help build the community around this. We want to work with folks just like you to see what kind of data sets you have that you might want to bring to the table and mash up with some of our federal data sets. And then really what that will do is it'll allow us to all construct new data sets that will be able to expand the benefits and the innovation for all of us. So we're really excited about the possibility of that and what these new data sets will bring to the table. And then there's this idea of the data lake, right? So the data lake is something that we're building as a starting point on AWS. And this data lake will really enable faster, easier analysis of our data, easier computation, and like I said, it will allow us to easily mash up data to create new innovative data sets that maybe have never been even developed before. We're hoping that this will also develop new businesses, new web tools, things like that, that will accelerate the energy market as well. And then there's the whole idea of analyzing big data without making really expensive hardware investments. You know, NREL has a supercomputer at our fingertips, but not everybody does. So this data lake concept will really allow people to touch large data sets, use large data sets in a way that they've never been able to do before, and they could do that just using their laptops. So this is kind of a high-level view of the data lake concept. The idea is that energy data will be coming in through a lot of different ways, potentially resource data like we just showed, but there's also lots of data catalogs that we manage. There's a lot of performance data that's out there. There's laboratory and research data that's out there. There's all sorts of data that's out there that hopefully will kind of either be in this data lake or in other data lakes potentially that are near this data lake and easily shared. And then within the data lake itself is where the analytics and kind of the magic can happen using some of the analytics tools that are offered through Amazon. And then the users of this data lake will be able to mash up their data, create new amazing data sets, and be able to take those data sets away for their own purposes, their own research, to build their own businesses or to create their own new innovations. In addition, we're building a data catalog, a metadata catalog that's really all about the data and describing the data. It's modeled after something that we created for OpenEI. Like I said, OpenEI has been around for around 10 years. We have lots of great high-value data in that platform, which you can go to at openei.org. And it has a catalog that we're going to be kind of building off of and leveraging for the Open Energy Data Initiative project. But the beautiful thing is that we're going to be providing Jupyter notebooks in this catalog to show people kind of some examples of how they can use the data. We'll provide links, data provenance, licensing, etc. Like I said, it's built off of the OpenEI data catalog as well as some others, the geothermal data repository as well as the marine hydrokinetic data repository are both data catalogs or data repositories that use the same sort of back-end technology, and we're leveraging kind of like all of this to create kind of a new innovative way for you guys to get access to this data. I did mention Jupyter notebooks and some use cases, and that's what we're trying to kind of, we're working on to populate so that so a researcher or someone coming to this platform will be able to see you know, some examples and use cases of how some of these data sets can be used. So that's all things that we are actively working on now. Also, we're looking to target initial data sets. So this is just a sampling of some. We have a lot more on our list actually of where we want to go. And of course, we're starting with some of the data sets that NREL owns and knows very well. But I do want to throw this out there to the community that we are interested in all kinds of high-value data sets. So if you are a data owner and you have data that you think would be interesting to put into this data lake concept and interesting to mash up, perhaps with resource data or maybe utility rate data or cities information or things like that, we are all ears and we would love to hear the kind of data sets that you have. And yeah, we would love to talk to you about the data you have or potentially the data you would like to see that is not included in there today. So now I'm going to turn this over to David Rager. He is the technical lead on actually creating the actual data lake as it is. So go take it away, David.
Thanks. Yeah, my name is Dave Rager. I'm a cloud engineer here at NREL. Been here a number of years and helped launch this project about a year ago. part of the idea of the project was to set up the data lake, and part of the reason to put effort into a data lake is simply because the amount and size of data that's being generated these days makes it difficult to work with. I've done a lot of work as a data engineer as well, and understand some of the challenges with working with data, having to download it, format it, and do the ETL process, put it into your own data storage, that type of stuff. So what we see here is the first version of the data lake. We are leveraging the cloud to make this available, mainly because of the size of the data, but this also allows us to kind of leverage some of those tools for analysis without folks having to make big investments in local hardware and that type of thing. So this kind of shows you a little bit of those services. We have agreements with Amazon to store data in S3 in their open data program. Once it's there, we're able to then leverage some other services such as Blue and Athena to make that available in different methods to users who may be using Jupyter Notebooks, Tableau, other type of tools like that. One of the other projects that we are also implementing, since AWS's tools that they provide do not cover every data format that we want to address. We have a custom tool for the HDF format data that we place into AWS's S3 at the moment. That data will eventually be going into Google probably as well. But NREL maintains what we call the HSDS, Highly Scalable Distributed Service in Amazon for access to the data sets that Michael was talking about in SRDB and the Win toolkit. Again, these are very large data sets, difficult to work with, but this makes it a lot simpler. So we maintain basically a cluster which has the smarts to go pull chunks of data out of S3 when requested by users from their own Jupyter notebooks. That service is fairly valuable. You get some parallel processing of chunk data so that you get a response pretty quickly for subsets of data, assuming they're not extremely huge, that you can then work with in a Jupyter notebook with near real-time results. Some of the AWS services that we're leveraging try to kind of use that same methodology. They provide a way to do this with Parquet files and org files, CSVs, that type of stuff, using the PrestoDB project. So what we are doing in that case is we are formatting data typically in Parquet. We'll be placing it in S3. That makes it pretty accessible by Jupyter Notebooks or Spark or analysis tools that you may already have, but it also opens up the possibility of using Athena for SQL queries directly off of the data in S3. So part of the project effort is we are putting the effort into formatting the data, typically in Parquet, but cleaning it up, making sure it's easy to use. We partition it so the chunks are appropriate for the queries that we expect to be happening. We do create table definitions that you can run SQL off of, and we also provide examples on how to use that, which is typically with stuff like PyAthena or a JDBC connection, that type of thing. So hopefully that's fairly accessible to most folks who are familiar with SQL interfaces, and will hopefully make working with large data sets simpler again. So some of the benefits, partition schemes are designed to support queries and targeted downloads. We support out-of-the-box SQL again. It's a low cost. I mean, to use some of the Amazon services, we provide code to get you started with that, but they do charge for some throughput. It's typically pretty low. I think I mentioned it's like $5 per terabyte of data scanned. So there is a little bit of cost associated with this type of data access. And then once you are in there, you have a lot of flexibility with moving data around. You can, for instance, create your own subsets of the data in S3 and use a similar method to kind of join that and mash it up with other data sets.
Cool. Thank you, David. So basically, yeah, the bottom line is that this is the project and what we're working on, and really what we're trying to do now with our partnership with LF Energy is to open up OEDI really to the world, right? We want to build a open source community around this project. We want to look to collect data, build new use cases with the community input. So we really hope that you can join us and help provide data sets, help maybe create Jupyter notebooks or other applications off of some of this data, even help us test the platform as we go into development and things like that. Where we are right now is we are in active development. This is a relatively new project. We've been actually working on it for about a year now, but a lot of it has been kind of like, creating kind of the structure of where we were going and starting to look for the data sets. So we're still in active build mode. We are building the metadata catalog now. We are still trying to build the alpha version of the data lake itself. We're gathering and integrating data sets. We are building the relationships with the cloud partners that we talked about. We're working on Jupyter notebooks to really showcase some of the data sets and show off how the data can be used. And then we're continuing to collaborate with the HDF group to improve our HSDS performance. And then we're obviously our new partnership with the Linux Foundation and LF Energy. We're really excited about that, and we really are starting to build the open source community around this project as well. So if you have any questions, here is Michael, Rossol, and my email contact, so you could reach out to us. Like I said, if you have data, if you are a data user, if you want to be part of the team, part of the technical steering committee, we welcome your participation. So I guess we could turn it over to questions.
If anybody has any questions, just either raise your hand or pop them up on the Q&A box. Really a great consolidated talk about the entire thing. That was really useful.
Great, thanks.
Not seeing any questions, and I think maybe you've answered everything already.
Okay, that's perfect.
So certainly, oh wait, here we go. No question at the moment, but really interesting and great presentation indeed. Thank you very much. So you can also always follow up with Debbie or Michael directly. I would really encourage you to go to lists.lfenergy.org and join the mailing lists there, which exist. It's a great way to ask future questions and to get involved with the project and to get more involved with LF Energy in general. And I guess if there are no other questions, we can go ahead and wrap up. So thank you very much to everybody at NREL for putting this together and for working so hard on making this data available. I think it's extremely useful for the energy world and just for the world in general. And thank you all for joining us on this webinar. We'll have the recording of it up hopefully by the end of the day.
Great. Thank you so much.
Thank you.